Okay, for this problem, you're looking at strings and it says they differ only in length, therefore they must be of the same material. They're attached to one oscillator, they're fixed at one end, and they have the same tension. The oscillator creates a transverse wave, and it's tuned to the fundamental frequency of a standing wave on the shorter string. So we want to know why you don't have a standing wave on the longer string. Well, the first option says that the waves travel at slightly different speeds on the two strings, but if they are made of the same material and they are at the same tension, then the speed doesn't change as long as the medium is the same. Now, if you change the tension of one of them or if you change the material of the string, then that would be a possibility. An oscillator frequency that results in a standing wave on a string of one length cannot result in a standing wave on a string of a different length. That's not true. There are certain lengths for which you could conceivably produce a standing wave. And that's not a pretty standing wave, but a standing wave on one and actually have a standing wave on the other. They just need to be the right ratio, basically. So that's not going to be true. The amplitude of the wave does not match the boundary conditions for strings of different length at the same time. It's not the amplitude that's important in creating standing waves. It is instead the frequency that is important in creating standing waves. So the wavelength associated with the given frequency does not match the boundary conditions set by the length of the longer string. You may not know what boundary conditions mean, but the fact that it's talking about the frequency, which is the most important characteristic for creating a standing wave, and the fact that you can rule out all the other answer choices makes D the correct answer. And if we check the answer key, we'll see that D is indeed correct because you have to have a length that's of the proper ratio so that you can create standing waves on a string. And so there's your answer.